In this video, I'm going to break down production and cost and give you some examples similar to what you'll see on the homework and on the exam. So starting with production, and this chapter starts off by looking at production. Now, production we're talking about in the economic sense is going to be the transformation of inputs. And in chapter 1, we talked about our different types of inputs or our factors of production, so land, labor, capital, entrepreneurship, things like that. So when we look at the production process, it's going to be how we're transferring those inputs or those factors of production into goods and services or outputs. So that's what the production process centers around, transferring these inputs into outputs. Now, when we look at our inputs, there's going to be two types that we're going to be focusing on. Now, the first one is going to be our fixed inputs. Now, when we talk about fixed inputs, as the name implies, that these are inputs that cannot be changed in a given amount of time. So the inputs are fixed. So that could be some examples like your building space or the amount of equipment that the firm has on hand. So these typically become more of like your big ticket items or contractual obligations, things that you can't easily change. So if you have a manager making $60,000 a year for a firm, that's going to be a fixed input because once again, that's a contractual obligation. Or it could be the lease on your building. So set monthly payments, things that don't alter. Now, the other type of input that we have are these variable inputs. And as the name implies, these are inputs whose level can easily be changed. So you can easily increase or decrease these variable inputs depending on the needs for your firm or your business. Now we're going to be focusing mostly on the short run. So there's two time horizons. We either have the short run or the long run. But as I mentioned, for this semester, all we're going to be focusing on is the short run. And the way that the short run is broken down is this is going to be the time period where at least one input is fixed, and then also at least one input is variable. Now, as we look at those types of inputs, we're going to see that the fixed variable, so our fixed variable is usually going to be our capital. So typically capital is going to be fixed. So this could be the amount of equipment that you have, this could be assembly lines, the building capacity. All these things are fixed, once again, not easily altered. And then we're also going to assume that our variable input is going to be labor. So firms can easily have their workers work additional hours or less hours as needed, which makes our labor variable. So if we're looking at a pizza place, if consumers are constantly going in and buying pizzas, or if it's a very popular time to get pizzas, the pizza place can have their workers work longer hours or pay them overtime. And conversely, if it's a time where sales are really slow, the manager can also cut back on the amount of hours. So once again, we're going to assume that our variable input is going to be labor. So labor is always going to be abbreviated with an L, and then capital is typically abbreviated with a lowercase k. So let's look at our measures of short-run productivity as discussed in the chapter. Now, the first measure of productivity, or at least short-run productivity, is going to be our total product. Now, total product is going to show the maximum produced given various levels of capital, K, and our labor, L. So when we talk about our total product, this is going to be the same as what we've been referring to it as previously. So our output, or it could be the quantity that's produced, or we've just been abbreviating it as Q. So whenever we're talking about our total product, that's just going to show us the maximum produced given the amount of workers we have and the amount of capital equipment that we have as well. So total product, once again, is going to measure the total productivity of a production process, and it's just simply how many units can be produced in a given period of time. Now, our second measure of short-run productivity is going to be our marginal product. Now, if you remember, the term marginal just means additional. So we're looking at our marginal product, which is abbreviated as MP. This is going to measure the change in total product when the level of a variable input is changed. So when the level of a variable, of our variable input, and if you recall, we said that our variable input is going to be labor. So when the level of that variable input is changed. So we have a simple formula to find our marginal product. So our marginal product is going to be equal to our change in total product over our change in labor. Because as the name implies, we said it measures the change in total product when the level of our variable input, so when labor, is changed. So we can always find our marginal product by taking the change in total product divided by our change in labor. Now, marginal product is going to be very important because we're going to see that as we increase labor by 1 unit, we're going to see the contribution that each additional worker adds to the overall production process. So marginal product is an individual measure of productivity. Is an individual measure of productivity. In a sense that it tells us each worker's an individual contribution to the firm's output level. Now, our third measure of short-run productivity is going to be our average product. Now, our average product measures the average, as the name implies, the average productivity level of our variable input, once again, which is labor. Now, the same way that you will find the average of anything, you just take the total and divide it by however many you have. So our average product is going to be equal to our total product divided by the amount of workers that we have, or our labor. So our average product is also referred to as like our labor productivity. So sometimes instead of using an individual measure of productivity like our marginal product, we might want to look at the entire labor force or the subset of the labor force and measure its collective productivity. So average product is most commonly going to be used to compare productivity levels across different production sites or across countries in some instances. So we can have like a McDonald's on the north side of town, and we can have a McDonald's on the south side of town. And we can see which site is more productive by looking at their average product. So let's look at a numerical example. So typically I will give you the amount of capital that we have, our labor, and let me go ahead and just put in our total product. So these are just arbitrary numbers. And given our total product, so once again, it's just telling us based on the amount of machines that we have. So actually, let me make this a little bit easier. Let's just say that we have one pizza oven that we run for 10 hours a day instead of just looking at 10 hours. So we have one pizza oven. And we have our different levels of labor. So these are all the different amount of workers that we can have. And we see that as we increase the amount of workers, that's going to allow our total product or our output to change. So let's find our marginal product. So once again, marginal product is going to be equal to our change in total product over our change in labor. And it's telling us an individual measure of productivity. So as we go from 0 workers to 1 worker, we're going to look at how much does our total product change. So we see that it's going up by 10. Our labor is increasing by 1. So 10 over 1 is going to give us 10. So with a marginal product of 10, that says that that first worker adds an additional 10, let's say, pizzas to the production. So let's go to the second worker. As we go from 10 to 22, that's a change of 12. So total product is increasing by 12, and our labor is increasing by 1 again. So 12 over 1 gives us 12. So we see that the second worker adds an additional 12 pizzas to the production process. And then we can just keep going and finding our marginal product. Luckily, all these are going to go up in increments of 1. So it's going to make it really easy for us to find our marginal product. So as we go from 22 to 33, that's a change of 11. As we go from 33 to 42, that's a change of 9. As we go from 42 to 42, we see that that does not change. And then as we go from 42 to 40, that's going to be a change of -2. And your marginal product can be negative, and we'll explain what that means when marginal product is negative in just a moment. So we have our marginal product column, so let's also go and find our average product. Average product is going to be equal to our total product divided by labor. So we're just going to take 10 over 1 because we have our total product here and the amount of workers that we have here. So 10 over 1 is going to give us 10. When we have 2 workers, we're able to produce 22 pizzas. So 22 divided by 2 is going to give us 11. When we have 3 workers are able to produce a total of 33 pizzas. So total product is 33 over 3. Once again, it gives us 11. When we have 4 workers, they're able to produce 42 pizzas. So 42 divided by 4 is going to give us 10.5. Once again, 42 pizzas are produced by 5 workers. So when we have 5 workers, we're producing 42. So 42 divided by 5 is going to give us 8.4. And then our last one, we see that when we have 6 workers, they're able to produce 40 pizzas. So 40 over 6 is going to give us 6.67. So we found our average product once again by just saying, based on the amount of workers we have and the amount that they're able to produce, what's the average? All right, so let's move forward and start finding our stages of production. So there's going to be 3 stages of production, which we'll be able to identify based on our total productivity and our marginal productivity. And there's going to be a term that we're going to use for each of the 3 stages for production. So stage 1 of production, we'll be able to identify stage 1 by looking at total productivity and then marginal productivity. Now, during stage 1 of production, we'll see that total productivity increases at an increasing rate. Total productivity is increasing at an increasing rate. And if we look at marginal productivity, we're going to see that it increases to its maximum point. So marginal productivity increases to its maximum point. So let's go back to our table down here. Now, if we look at our marginal product, where is it at its highest point? It's going to be right here at 12. So we can say that stage 1 of production is from 0 workers to 2 workers, where we see that our marginal productivity is at its highest. So the marginal product is actually going to tell us the rate of our total productivity. So it's, if you've taken calculus, it's going to be the first derivative of our total productivity function. So marginal productivity, once again, is going to increase to its maximum point. Now, during stage 1, we have what is called increasing marginal returns. Increasing marginal returns. Now, this just means that each additional worker So each additional worker contributes more than the previous. So each additional worker contributes more than the previous worker. Now, let's say we're looking at this pizzeria, and let's say that there's only one person working. So let's say that I'm the owner of this pizzeria and I'm the only one person working and I'm able to produce 10 pizzas on my own. Now, if I'm the only one working, that means that I'm going to have to do everything. I'm going to have to accept the orders. I'm going to have to accept the payment for the orders. I'll have to prep the pizzas, bake the pizzas, put the toppings on the pizzas, deliver them to the customers' tables. So I'm doing everything. But as I hire another worker, so maybe as I hire this second worker here, we see that my total productivity goes up. So they're contributing more than what I was able to do on my own. And the reason why they're able to contribute more, or that our total productivity goes up altogether, is because we can specialize or divide up the task. So whenever we have increasing marginal returns, this is going to be due to specialization and division of labor. So when I was just working by myself, once again, I was doing all the tasks. But now as I hire an additional worker, I'm able to split those tasks up and I can do all the things that I'm proficient in and the other worker can do all the things that they're really good at, which allows us to be more productive collectively. So once again, this occurred from labor unit 0 to labor unit 2. Yep, so from labor unit 0 to labor unit 2. So, stage 2 of production. During stage 2 of production, we're going to see that total productivity is still increasing, but it's going to be at a decreasing rate. Total productivity is still going up, but it's going up at a slower rate. Now, if we're paying attention to marginal productivity during stage 2, we're going to see that it decreases to 0. So once again, focusing on marginal product when it decreases to 0. So stage 2 of production is going to be from labor units 3 to labor units 5. Now, during stage 2 of production, we have what is called diminishing marginal returns. Now, during stage 1, we had increasing marginal returns, which meant that every additional worker was contributing more than the previous. But now in stage 2, when we have diminishing marginal returns, this means that each additional worker contributes less than the previous. Each additional worker contributes less than the previous worker. And as I already wrote in here, this is going to be due to fixed capital. So if there's only one pizza oven, there's only so many pizzas that can be prepared and baked at the same time. So we have diminishing marginal returns. So once again, that just means that each additional worker is contributing less than the previous. Now let's say that instead of 0 here, this was 1. It would still be stage 2 from labor units 3 to labor units 5. If it doesn't go to 0, it'll be the last positive number that occurs for marginal product. All right, so we have stage 2. So let's look at our last stage. So we're going to have stage 3. Now during stage 3 of production, we're going to see that total productivity decreases. So we're producing less. So if we're paying attention to marginal product, that means that marginal product is going to be a negative number, which means that we have negative marginal returns. Negative marginal returns. Now, when we have negative marginal returns, this means that each additional worker actually reduces total product. So reduces total product. And in a sense, they're kind of harming the firm because they're making production to go down. Now, we never want to be in stage 3, and this typically occurs due to overcrowding. You have too many people getting in each other's way. So this could be overcrowding or even coordination problems, which can be due to maybe the order that things are occurring. So let's find stage 3 in our table here. So it will just be right here. Once again, we see that total productivity decreased from 42 to 40. And we also see that our marginal product is a negative number. Now, you never want to be in stage 3 of production because once again, we see that each additional worker that we're hiring is actually harming the firm and we're causing our production to go down. Now, the $1 million question is, how many workers should this firm hire? So how many workers should the firm hire based on our example here? Now, based on our example here, we're going to see that the firm should hire 4 workers. The firm should hire 4 workers. And the reason why is because you always want to hire as long as the marginal productivity is greater than 0. So you'll hire a worker as long as they're able to contribute something to the production process. So hire as long as marginal productivity is greater than 0. Because if the marginal productivity is 0, that means that that worker that you hire is not going to contribute anything to your production process. So why would you want to hire that worker? So as long as they're contributing something to it, we're going to hire that person. So once again, in our example here, it's going to be 4 workers. All right. So let's switch gears and look at cost. Now we have 7 different types of cost that we went over in the PowerPoint slides. So I'm just going to very briefly go over them again and then also give you an example of calculating all the different costs when you see them in a table. So the first one that we have are our fixed costs. So this is going to be the cost of all inputs that are fixed, cost of all inputs that are fixed in the short run. And as the name implies, these costs do not vary as output goes up. So if your fixed costs are $50, if you're not producing anything, your fixed costs are going to remain $50. So once again, fixed costs do not alternate at all. And then let's see, I'll give you some helpful tips just in case you see this on your exam. So whatever fixed costs are when quantity is equal to 0 will be your fixed costs at all output levels. So whatever your total fixed costs are when you're not producing anything, that's going to be your fixed cost at all production levels. Now our next one that we have are our variable costs. Now our variable costs are going to be the cost, once again, of all of our variable inputs used in producing a particular level of output. So if you're producing 3 units, your variable costs are going to be different than if you were producing, say, 8 units. So let's look at that. Now, when your quantity is 0, if you're not producing anything, then you will not have any variable costs. So what we'll see is that total variable cost is going to be equal to 0 whenever our quantity is equal to 0. Because once again, if you're not producing anything, you're not going to have any costs that are associated with that. So we have our total fixed costs, we have our total variable costs, and then our next one are our total costs. Now, as the name implies, total cost, this is just going to be the sum of all of our costs, our fixed costs and our variable costs. So we're just adding the two together. Now, if we don't have any total variable costs when our quantity is equal to 0, just a little helpful tip. Whenever our quantity is equal to 0, there are no variable costs. Therefore, our total cost will be equal to our total fixed cost whenever our quantity is 0. That is going to be a helpful tip. So whenever your quantity is equal to 0, as we've already established, there are no variable costs. Therefore, your total costs are always going to be equal to your fixed costs whenever your quantity is equal to 0. Next, we have our marginal costs. So our marginal cost is going to be the additional cost. The term marginal just means additional. So this is going to be the increase in total cost from producing one more unit of output. So this is going to be our change in total costs divided by our change in quantity. So for example, if 2 pizzas cost a total of $12 to make, and 3 pizzas cost a total of $15 to make, then that third pizza is going to add an additional $3 to our total cost. So that's going to be our marginal cost. Now the last 3 are all going to be averages. So our average fixed cost is just our total fixed cost divided by the quantity of our output produced. So this is going to give us an estimate of our fixed costs per unit. So for our average fixed cost, it's just your total fixed cost divided by your quantity. Now what we'll see is that our average fixed cost is going to decrease as our production increases. So the more you produce, the lower your average fixed costs are as you're able to spread those fixed costs over more and more units. Now our average variable cost is going to be our total variable cost divided by the quantity that's being produced. And this is going to give us an estimate of our variable costs per unit. So our variable cost per unit. And we'll be able to find that by taking our total variable costs and dividing that by our quantity. And then lastly, we have our average total cost, which is our total cost divided by the quantity. And this gives us an estimate of our overall final cost of production. Now this is going to be very helpful in our next chapter when we're trying to find our profit per unit. We're going to take our revenue per unit minus our total cost per unit. So that's where average total cost is going to come into play. Now, as you see, there's 2 different ways for us to find our average total cost. We can either take our total cost divided by our quantity, or we can just take our average fixed costs and add our average variable costs together. So let's look at an example of all the different costs combining all the different costs and seeing how we can calculate everything. So the best way to fill these out are to go left to right instead of trying to skip around. Now, first off, if we know that our fixed costs are $20 when our quantity is equal to 0, as we talked about with our fixed costs, Whatever fixed costs are when quantity is equal to 0 will be your fixed cost at all of the output levels. So if it's 20 when our quantity is equal to 0, it's going to be 20 when our quantity is 1, 20 when our quantity is 2, and so forth. So now that we know our fixed costs, we have our variable costs, we can easily find our total costs. So total cost is going to be equal to our total fixed costs plus our total variable costs. So 20 plus 0 is equal to 20. And I guess we can just fill out columns since we have the information. So 20 plus 11 is going to be equal to 31. 20 plus our 20 is going to give us 40. We'll have 48, 59, 75, and then once again 20 plus 80 is going to give us 100. So we have our total costs. Once again, just the sum of all of our costs, both fixed and variable. Next, let's find our marginal costs, which is going to be our change in total costs over our change in quantity. So as we go from 20 to 31, our change in total costs is going to be 11. Our change in quantity as we go from 0 to 1 is 1. 11 over 1 gives us 11. As we go from 31 to 40, that's going to be a change of 9. Once again, our quantity is going up in increments of 1, so just 9. And luckily, all of them are going up. Our quantities are each increasing by 1. So as we go from 40 to 48, it's a change of 8. From 48 to 59, it's a change of 11. From 59 to 75 is going to be a change of 16. And lastly, from 75 to 100, it's going to be a change of 25. So let's get our average fixed costs. Average fixed cost is just going to be our total fixed costs divided by our quantity. So as we take 20 divided by, so we have our 20 divided by 1, which gives us 20. 20 divided by 2, which is going to give us 10. As we take our 20 divided by 3, that's going to give us 6.67. 20 divided by 4 is going to be 5. 20 divided by 5 is going to be 4. And then lastly, when we take our 20 divided by 6, that is going to give us 3.3. Now, as I mentioned earlier, we see that as our average fixed costs, or as our average fixed cost goes down as we produce more, because once again, we're able to spread those fixed costs over more units. So let's find our average variable costs. Average variable cost is going to be our total variable costs over our quantity. So we have our total variable cost, so 11 over 1 is going to give us 11. When we take our 20 divided by 2, it's going to give us our 10. When we take our 28 divided by 3, that is going to give us 9.33. So 28 divided by 3 is going to give us 9.33. 39 divided by 4 is going to give us 9.75. 55 divided by 5 is going to give us 11. And then lastly, 80 divided by 6 is going to give us 13.33. And then for our average total costs, we can either take our total costs divided by quantity, or we can take our average fixed costs plus our average variable costs. So 20 plus 11 is going to give us 31, or we can take 31 divided by 1. So sometimes it's just easier to add your average fixed and your average variable. 10 plus 10 is going to give us 20. If we were to take 48 divided by 3, that will give us 16. Or if we took 9.33 plus 6.67, that will also give us 16. 5 plus 9.75 is going to give us 14.75. 4 plus 11 is going to give us 15. And then if we wanted to take 100 divided by 6, that will give us 16.67. Or we could add 3.3 plus 13.33, and that will give us 16.67. So this is just an example of how you would utilize all of your cost formulas, so all 7 of them, and finding our different costs. So please let me know if you have any questions.